because of that continuous pull. We do custom materials, again, targeting production applications, knowing people have different requirements. We formulate materials specifically for your need to be able to take advantage of our system. First public customer, Wilson, taking over the pickleball world, which is the fastest growing sport of all time in the United States. Thank you.
Thank you so much. Great presentation. Questions from the audience? There's one. Can we repeat the question quickly? Sorry.
Yeah, what's the business model, and do we sell printers or do we contract manufacture? We lease printers and we sell material. We will do some part production as needed to get the business off the ground and get parts in people's hands, but it's not the end business model.
Thank you so much. Any more questions? Then thank you so much for being here. Applause, please. So I hope you have enough energy left, because we are now coming to our last session where we come to startups from the areas of software and services. We are going to start with 3D Spark, and they want to answer quickly the question, which component can be printed? Ruben Meuth, co-founder and CEO, will guide us through the topic. Ruben, the mic is yours. Please.
Thank you very much. Hi, everybody. I'm Ruben Meuth, one of the co-founders of 3D Spark. And when it comes to the adoption of 3D printing, unfortunately, my presentation was not changed. Can we switch to another presentation and I switch the presentation? Is that possible? It's not possible? That's quite different. Okay. So when it comes to the adoption of 3D printing, we see different challenges. Number one, with 3D printing service providers, like MedShape, actually, a great company. Go check them out here. Their head of sales says costing, quoting is a big challenge, very annoying and time-consuming for them. And why is that? Because every morning he opens his inbox and has a lot of RFQs, so requests for quotations. That's exactly what he wants. It's great. But it means a lot of manual analysis. So forwarding CAD files, drawings to his technology experts. They check for printability, so feature sizes, distortion, for example, and feedback that information, as well as some metadata, some information they get from the CAD files, like bounding box, volume, and then he feeds that into his Excel tool to do the quoting. So that process works. It's, however, a bit lengthy, involves a lot of tools, and it doesn't scale. That's one problem. Next one is with larger OEMs, like Alstom, for example, world-leading manufacturer of trains, like TGV, and they set themselves the goal to reduce cost and lead time on a global basis. And they identified 3D printing actually to be one good solution for that. And in charge of that is Orion Fussell, 3D printing program manager. And he quickly realized that to meet those high set targets, he needed to get as many people as possible, as many employees as possible, of 75,000 employees, involved in the process in 3D printing. And once he started doing that, a lot of questions started pouring in, like, is my part printable? What's the best process? What's the best material? And obviously, how much will it cost? And so just far too many requests. And on the other side, management always asking on a monthly basis, what is the current status of the project? Are we saving costs? How much cost are we saving? How much lead time are we saving? And so it became very quickly clear that a software was needed to answer for all these requests. And that's why we created 3D Spark. The comparison engine for components. And what you drop in is CAD files, drawings, metadata, and what you receive is printability checks, instant costing, process comparison, and soon a CO2 footprint calculation. And that to give a transparent basis for decision making, right? And we're very happy that Alstom, for example, has saved 1.8 million euros in cost and more than 20,000 days of lead time with the help of 3D Spark. And I'm not sure if there's a... Also, that slide is missing.
That's the best way to do it, honestly. Awesome. Still an awesome presentation, believe me. I think we got the point. So you mentioned Alstom. Are there any customers or applications where your software already helped in finding the right parts to print?
Yeah, so in this case, the railway industry, we identified more than 600 validated use cases. Again, they were printed in with various different technologies, and with that we were able to save these 1.8 million euros in cost. And on the other side, the service or the manufacturing service providers, they do their quoting with our software.
So if you mention an railway, are you then rather focusing Deutsche Bahn, for example, or the producers of trains?
Both. More the producers, but I may say Deutsche Bahn is also a customer of ours, actually. And they also use our software because they do both, actually. They do sourcing, so we help with the sourcing, make or buy decision, for example. But also they produce themselves since recently. They have their own printers, so they also need to do their own quoting, actually.
Great, great presentation. Any questions from the audience? If not, I say thank you so much. It was very spontaneous and still very good. Thank you so much. Ruben. Quality assurance remains eminently important, especially in 3D printing, and we heard a lot about this already today. And the whole thing is developing quite rapidly. Fully automated, retrofittable, and remotely controllable is what many companies want. Additive Assurance is tackling the issue and presenting its solution here at Formnext, and more importantly, here at the Pitchnext event. It's a pleasure to have you here. Welcome, Marten Jung, CEO of Additive Assurance. Marten, please.
Thank you very much, and good afternoon, everyone. My name is Marten Jurg. I'm one of the co-founders of Additive Assurance, and we provide quality assurance for laser powder bed fusion. Now, laser powder bed fusion is rapidly moving from a case where it was printing individual parts and prototypes into a case where you're making many of the same part in batch or serial production. As an industry, this is incredibly exciting that we're at this tipping point now after these many, many years of production and development. But the difficulty now becomes, how do you identify the non-conformances inside a batch? The methods of quality assurance for additive manufacturing are still somewhat limited by our traditional techniques of inspection. So this is what we're working on directly. Apologies, there's been a bit of a formatting issue here by the looks of it. But in situ monitoring enables us to unlock the value of additive manufacturing through inspecting every layer, layer by layer, to identify any anomalies that occur in your parts. The benefit here is that if you can do this across a series of parts, you can quickly establish metrics that enables you to determine quality specifications for your entire production series. And this is really unlocking that next stage of capability. We've developed a proprietary methodology that is a long exposure-based technique that's both data efficient and also very fast to analyze these parts and results. So how do we do that? We've developed a sensor package, analytics suite, and a methodology to deliver this back to the customer. So it's an all-in-one encompassing package that we sell as a subscription service to the end user. It's on the market today, by the way. So how we do this, we have a retrofittable sensor package you can see on the left there. This enables you to capture detail of the process down to the micron level, greater than 30 microns per pixel across the entire powder bed. That enables you to identify those small anomalies in that laser powder bed fusion process that is so critical to establishing quality specifications. On top of this, we've developed machine learning-based algorithms to identify those fluctuations and categorize them in terms of the type of defect that may be occurring inside your part. And finally, we developed a cloud-based platform, to identify and deliver these indications back to the user so that you can do so with confidence and deliver this to a production floor without having PhDs running the machines, which has been previously quite common. So our optical-based methodology, it's a long exposure-based technique and can be mounted externally or internally. We're working with a few OEMs to do this internally currently. This external mounted system, though, can be applied to any of the major vendors that are currently on the market today. So come and speak to us later if you want to learn more about this. The other benefit is that it is agnostic to the number of lasers and has no impact at all on your machine warranty. I'll leave it there for now, but I encourage you to come and visit us over at Hall 12, where we can dive into more detail about how you can actually use process monitoring to establish that confidence across all of the parts. Yeah, I'd like to encourage you to come over to Hall 12, Level B. Thanks.
Thank you so much. Awesome. Okie dokie. I'm really excited about the next presenter because it's very similar, at least. Welcome. Finding anomalies in the early stage of printing is one of additive monitoring. You are now called Phase 3D. You just renamed, I heard that.
Yes, that's right.
That's why you have this cool jacket, by the way.
Thank you.
Looks awesome, yeah. You are Niall O'Dowd. Is that correctly pronounced?
Yes.
Yeah, is Irish or what is it?
Yeah, it's Irish, yeah.
What is the correct pronunciation?
Oh, yeah. My name's Niall O'Dowd.
Okay, great. So you explain us how it works. Please, stage is yours.
Yeah. Good afternoon, everyone. Thanks for attending. Excited to share some information. My name's Dr. Niall O'Dowd. I'm the CEO and founder of Phase 3D, and we're doing in-situ monitoring for additive manufacturing. So, as I bet we can all agree, I believe AM can really dominate complex manufacturing. It's an awesome platform for part repair, weight and cost savings, as well as building complex, impossible to manufacture parts just several decades ago. But there are several hindrances preventing even wider scale adoption of metal powder bed fusion and other metal AM processes. The part rejection costs, lengthy and costly post-inspection and post-processing can hold back adoption for aerospace components or automotive components that need to be produced fast and efficiently. Certification and qualification can be impossible in large, dense parts that can't be non-destructively tested. But I believe in-situ monitoring can solve these problems. For example, using an in-situ monitoring solution, we can find process anomalies and part defects during the process, which mitigates a lot of the cost and pain felt from part rejection. Also, because we can inspect the part as it's being made, it doesn't matter how large the part is or how dense the part is if we have access to those internal surfaces. So Phase 3D has invented an in-process monitoring system called Project Fringe, which can attach to any powder-based AM printer, detect defects throughout the printing process in every layer, and it allows users to plan strategically with real units. What makes us special is that we do layer inspection with real units, height mapping, so that users can define thresholds and statistical uncertainty without use of a black box or AI ML interpretation. So we're able to collect objective data during the printing process. Our data set is much smaller because we know the nominal condition using our height-based thresholding and signal processing. And we're also able to simply retrofit any printer just outside the build chamber to not impact warranty or any kind of gas flow or process parameters. This philosophy has really seen a lot of recent traction. We've been selected to do production environment development for the US Air Force, as well as funded by the Advanced Manufacturing Office in the US, as well as a collaboration with NASA Marshall Space Flight Center, where we're working on certification and qualification for their liquid engine printing process. I'd also like to announce the early adopter program. In January, we're starting a 6-month program where we're looking for contract manufacturers to to test and benchmark our system under a data sharing contract where we can reduce a lot of the license fees. Really excited about this program, and I encourage those of you who print parts and want to limit part rejection and improve certification processes to come reach out. We're exhibiting in Hall 12 downstairs.
What a timing. Thank you so much. Excellent presentation. Are there any questions from the audience? There's one, please.
Yeah. So the measurement is done during after the powder coating. So we look for defects like recoder streaks, hopping, short feeds, and then we do the measurement again after the melting or the sintering, looking for protrusions, hash spacing defects, spatter particles that combine and land on the part. So that two-stage process allows us to look for powder-based defects as well as the melted layer defects, and look between the difference in height between the powder layer and the melted layer to look for any kind of solidification, anomalies that may contribute to lack of fusion or keyhole porosity.
Awesome. Niall, thank you so much for being here. Faith 3D. Very excellent name. Good luck and very much success. And for any other questions, please join them at their booth. Thank you so much.
Thanks, everyone.
If we are talking about online demand printing, it's one of the great advantages of additive manufacturing. But at the same time, it requires a lot of time and resources to offer the service. This is where MARKLIX wants to help and offers a software as a service solution for this. Pierre-Jaques Lyon, I hope I put that correctly, CEO, will show us what is included in the solution. Please.
Thank you. So hi everyone, my name is Pierre-Jaques Lyon, and I am the co-founder and CEO of MARKLIX. And with MARKLIX, we are building a coating and planning solution. So our soft is completely white branded, so a service bureau can use it to take orders online. And some of them integrate it directly on their website. So they can allow their customer to upload 3D files and get a direct price and pay for their parts. So you can put a part, get a first test to test printability. Then you can pay, or you can also ask for an invoice if the service bureau don't want to show their prices. The pricing method we use is completely custom, so it's the pricing method of the services. We don't force the pricing method. That's something very important. And to do so, we integrate in the software a slicer, a nesting tool, and everything that is needed for the service bureau to do so. We are also working hard on a planning module that it's a second step after getting orders from clients. It's to manage the production, and some clients want also to know where the parts are, if the part is already produced or shipped, etc. We are a startup based in Aix-en-Provence, in south of France. And I co-founded this company with Thomas Boulier, that is actually the CTO of MARKLIX. We are followed and trusted by Bracken Darrell, that is Logitech's CEO since the beginning of the company. And we've launched this first product of coating in May this year. And we already have clients in Spain, France, Belgium, and also India. So we have a real traction and interest for our software. We are also some partners like IBM. We are reseller of IBM, so we can do on-premise also, and complex cloud integrations, and with VXS Orcas that have a security solution directly integrated into our software. So today we are focused on additive manufacturing. That's why we are here. And next step for us, it's also to do the same thing with traditional processes like machining or metal sheet work. Many thanks.
Thank you so much, also for the timing. There's a question from the audience, and please be so kind and repeat the questions for the online audience.
So the question is if we have a fee on the pricing or only a subscription. So it's only a subscription. It could be monthly or annual, and we adapt. We have different packs depending on the customer and the needs.
What would be interesting for me, what is your competition actually on the market? Are there other software suppliers that offering the same solution or pretty much?
Yeah, we have some competitors. For example, 3Omine, MFG, or Digifabster. What differentiates us from us is, first, we are moving to other technologies. Only for the moment, only Digifabster is doing the same thing, but Digifabster is not integrating a planning module. And also, I can't tell, but the best thing to do is to try every solution. And some clients are more happy with these competitors, others with us, depending on the interface and the user experience and some secret sauce we can have.
And you have showed in your presentation what would be the next steps. You're working on the production planner, for example. What do you need as a startup right now in order to proceed?
Mostly funds, because it's always running after time to develop everything. We have an amazing team of PhDs and engineers, but we need time to also to discuss with the customers and to build the products they want and not only what we want.
Very good. Excellent. Thank you so much.
Thank
Big
you.
applause for you.
Goodbye.
So if it comes to parts identification, this is one of the key challenges, and this often suffers from insufficient digitization. SelectAM offers a software solution here to identify as many parts as possible at once. And Niklas Kretzschmar, CEO and co-founder, introduces us to this topic. Niklas, stage is yours.
Yeah, thanks so much. So I'm Niklas Kretzschmar. I'm the co-founder and the CEO of SelectAM. So as mentioned, we focus on part identification, meaning finding the best business cases for additive manufacturing to really unlock the full potential of additive manufacturing. What we do is described here. So we provide, in the end, we provide information to companies on which parts to focus on. So taking a lot of data from those companies, screening down the data, and then handing over that data to OMS systems to get it finally printed. What is the problem of it? I mean, there's a lot of lost potential that we see because a proper part identification approach is not in place. You see 4 examples here. So often when we come to companies, we see that the data is not fully digitized. So often you don't have a CAD model or there's not all relevant information available. Secondly, the non-accessibility of AM in companies. So it's not linked to services or they don't have their own printers in place. So we can also fix that. Knowledge gaps related to additive manufacturing. Not in every organization you have a great knowledge in there, and our software can really support you in providing necessary knowledge because we default the software is data and also process agnostic. And also today the high cost when identifying parts. So today it's done really manually. You see an example here. So often a single part is uploaded to a platform with certain materials and machines, and then you get the feedback that this part is not printable. Then you get to go to another platform and so on. So that's really time consuming. We can do that all automatically with many, many parts at once, giving you the best recommendations for AM to use. So what is our solution? It's shown there. We hand over a template and if available, also some CAD data. And then we crunch that data from different aspects. So technical assessment, is this part printable from a technical side? All the technical requirements that are in there. Economically, if you have a printer in-house or you are using certain services, we can make or buy decision making there for each component and see if that's interesting. Then also from the redesign point of view, is it feasible to start a redesign process? Is it interesting to go into topology optimization and not? And finally, the supply chain assessment. So is that a problematic part from the supply chain? And we will figure out for you if it's, from that point of view, interesting as well. And then once you did that assessment for many, many components, then finally we connect you to an OMS system, and then you will get your parts printed and get all those benefits that are out there in additive manufacturing. So we just launched a software basically 2 months ago. There's a free trial you can use for 500 components to test it for. And as you can see, here's some economic assessments. So make a buy decision making on the upper right. And down there, it goes also into redesign. So we visualize the potential redesign potential of your part. And then you can, and then a designer can grab it from there and start the actual topology optimization process. So what is our mission? What is the vision after all? I mean, there's so many components out there that haven't been screened yet for additive manufacturing. And we have really a tool in place that can take 100,000 components, crunch them for different AM processes, different materials, and then we tell you which ones to focus on. So that is what we do. Because today, the adoption is still very poor, roughly 2.2%, and there's so much more potential with additive manufacturing. We are moving towards an AI, so this whole thing going to be fully automated and smarter than what it is today. And in the end, we will connect that system to ERP systems and later on to more OMS systems. Thank you.
Great, thank you so much. There's a question. So what is the go-to-market strategy of SelectAM?
Yes, so as you can see, we have this free trial option. So everyone who's willing to test the product can do that. And also we're evaluating to work with resellers, software resellers, that they will resell our product. So those are the main approaches. And of course, I mean, first time for us to be present at a trade show, also to get out there and to talk to a wider audience.
So that would lead to my question. What is currently your target group on the first step? I mean, of course, you're looking for trial users, but I'd rather bigger companies, smaller companies? What kind of companies are looking for such a solution?
Yes, so right now we have a handful of paying customers out there, and that's mostly really large companies, OEMs, with sometimes millions of components. And then what we see is also larger AM services, so those which are printing the parts. And finally, this is also interesting for redesign bureaus.
Very good. Awesome. Thank you so much. Any more questions? If not, they can visit, of course, you, SelectAM, at your booth. Thank you so much for being with us. Big applause for you.
Thanks.
Great to see you. Bye. So, coming to the next winner of the Startup Challenge, they tackle the issue of post-processing in metal additive manufacturing, and their solution is to reduce errors, risks, and costs. The CEO of Rivelin Robotics, I hope I put it correctly, yeah, introduces us how to do it. Welcome to the stage, Robert Busch, CEO of Rivelin Robotics. Please, welcome, and congratulations.
Thank you. Guten Tag. This year, Rivelin launched net-shaped robots. Net-shaped robots are for metal and for post-processing. Rivelin is the first company to fully integrate all of the post-processing steps. If you don't want the expense of a bandsaw or an EDM, you can get a Rivelin robot. If you don't want loads of guys removing supports, or you don't want to spend months of making reliable, consistent support-free builds, you can get a Rivelin robot. If you don't want a measurement step at the end of the line, but you want one in the line, you can get a Rivelin robot. And if you don't want batch finishing, but you'd rather targeted finishing for things like thermal insulation, flow efficiency, and fatigue, you can get a Rivelin robot. If you want to see it in action, you can check out our website, our homepage, rivelinrobotics.com. There's a video on the homepage. Essentially, our robots take a powder bed fusion part, for example, with supports on the platform, to a finished state. Automated, reliable, repeatable. And that's because Rivelin's robots cope with variability. There's 3 star cases. All are different, but one final output. We use a combination of machine learning and traditional deterministic control theory to achieve this. And it's important to stress that Rivelin NetShape doesn't need CNC programmers, and it doesn't need specialist robot programmers. You fixture it, and you hit the go button. Anyone can program. It's that simple. And this is what differentiates us from traditional casting automation. It's the lack of needing a predefined toolpath or a specialist robot programmer. So we get the repeatability of casting automation, but we get the flexibility of manual labor. So you can deploy robots faster and easier than ever before. Our secret weapon is our team. Ian Halliday has been a pioneer in additive for 30 years. And then the two Davids come from Rolls-Royce Additive Manufacturing and Rolls-Royce Robotics, respectively. So why have the likes of GKN Aerospace, Oerlikon, and Ministry of Defense invested in the support removal and targeted finishing solution from Rivelin Robotics? Well, they understand the pressing need to incorporate metal additive on their production lines, while also overcoming the challenges of post-processing by hand, such as lack of traceability, a lack of repeatability, spiraling costs, limited manpower, and risk to personnel. So keep calm and let a robot do it. Thank you.
Awesome. Thank you so much. I'm always keen on getting to know applications. So is there already an application in place where you implemented your system?
Yes. So at the moment, the customers that I spoke about, we're doing process validations. So they have particular parts, challenges. They tend to be support removal and finishing. And normally for scalability challenges, they can't get the personnel, or quality issues, or sometimes even cost. And we're going through those work packages, trying to prove that our system does in fact deliver what we say it does. And the outcome, if we succeed with all of them, is a deployment of a robot onto their line. Of the ones I said, Oerlikon, GKN, and Ministry of Defense, 2 of them are targeted for next year, if we go well, and the 3rd one for 2024.
What about the robot? Is that something you co-develop, or is that something you work with the common robot producer together?
This is a good question because lots of people ask this. Yeah, the robot is Japanese, Yaskawa.
Yeah.
We don't develop the robot. Our main, let's say, addition is the software. It's being able to control the sensors in closed loop and being able to program without actually needing to program. So just giving recipe steps.
So, and let me ask another question because I'm highly interested. So is there, like, if a company has already corresponding robots, do they need to buy the robot you are recommending, or is your software working with any robot out there?
We're providing a solution. So we sell our solution with a Yaskawa.
Okay.
It's not tied to Yaskawa. We could use a FANUC, an ABB, a KUKA.
Yeah.
But we're selling a solution, and so we like to partner with companies like Saint-Gobain, Yaskawa, because we can provide a better solution that way.
Very good.
So
Sorry
yes.
that I was asking all the questions, but it was super exciting. Thank you so much. Any questions from the audience? If not, I say thank you. See you later at the award ceremony, and it was great to have you here. Thank you so much. Big applause. So maximizing AM performance is the goal of Magnitude Innovations with their software as a service solution. If you look at their partnerships, in my opinion, they have already convinced important market players. I'm curious to see if they can do the same today with you here in the audience. And Tusz, who is founder and CEO, will try to do that, and I'm quite excited to see what kind of solution you brought with us. Matt, stage is yours.
Hello. No pressure. Yeah. For the record, this is the first time I'm ever doing this.
Okay. Go ahead.
So there's a lot of pressure. Is the thing
you
gonna
can
go
just
on?
go ahead.
No pressure. So hi. So my name is Matt. I'm the founder of Magnitude Innovations. We have a software, Optimal, which is not loading. So I'm just gonna freeball it. So
click. You have to click.
Oh, do I?
Yeah.
Oh, sorry.
Easy.
So I get another 10 seconds for that. So what we've done is we've created the first and only actually operational excellence software for metal additive. To date, we've raised over 330,000 euros through investments and grants. as well as we've been bootstrapping the rest of the way in terms of doing consulting for the industry because we have a lot of experience with that. So the team, the core team, are the 3 people here. I've been in the industry personally for 10 years. I've worked at NASA, EOS, with Siemens as well. And we founded the company 6 years ago, and we've been working on the software for 4 years now. So that there's a lot of work that goes into that, and we have a pretty awesome team that advises us, including people from the industry. And yeah, and so the problem that we're trying to solve is, and this is something that most people don't believe us about, is that the efficiency of metal systems is less than 50%. And it's a huge problem, obviously. Because if you look at any other industry where something is used for manufacturing, 40% efficiency is quite ridiculous. For 10 systems, that's about $2 million that are lost every year. And you're probably not believing me and asking yourself, why hasn't anybody else addressed this? Well, number one, because they don't know. There is no other way. There's nobody else that has actually measured the efficiency of production in metal AM. And for the most part, while we were doing this, people thought it was impossible. So our solution focuses on this idea that you're trying to run a system 24/7 at the perfect speed with perfect output. In each one of those dimensions, there's huge problems that lead to this kind of a reality, right? And so there's a lot of variables that go into this, and it's not that people are not competent to do this. The problem is they don't have the time. So what our solution does is it quantifies the efficiency of your production. It automates all these tasks that you have to spend on every day trying to figure out what is the strategy for today, what are we building, how are we going to optimize it, and then without requiring any tribal knowledge, doubles the productivity of your systems and also saves you a lot of time. So some of the key highlights are that like project managers save about 20 hours a week in terms of all the analysis that they have to do. Machine operators save about 5 hours. The team, in terms of review meetings, saves about 30 hours a week. And we've reduced inventory costs by about 1.5 million. And again, this is an example of 10 machine systems, or 10 machines running in production. So with regards to other companies that are in this space, we focus exclusively on operational excellence, not MES, not ERP. And then with regards to that, we have a huge advantage, but also from other companies that focus on OEE or efficiency, they're not in the industry, and so their solutions are very superficial, right? And you need a lot of knowledge in the industry in order to get to that conclusion of what to do. So with regards to the industry, we're focusing on having 1.2 million in annual recurring revenue by 2024. And obviously, the market is huge and it's growing, so I think there's a really great potential for that. And yeah, going to take your questions. I'll cut everything else
Awesome,
short.
awesome. Thank you so much.
Thank you.
What is your, yeah, big applause, worth it, definitely, definitely. What is the payment model you have right now?
I skipped that slide, but what we do in essence is...
Sorry for that.
No, that's totally fine. What we do in essence is we charge a minimum amount because of the fact that it's not just software, right? We're not just delivering you software and then we're going home. We actually go into the factory and help you implement operational excellence, which is a huge process, right? You have change management consultants for this. And so that's the other half of our team, which actually goes into the factory and helps you every week, every month, for the first year, to actually analyze what's going on and to save you that time so that then you can actually do your job better. In other words, delivering products to your customers, and then actually have the time to work on everything in more peace, right?
So there's a high part of consultation already also included, right?
In the beginning, yeah.
In the beginning, and the next thing would be, wouldn't it then be possible to like get a ratio of the savings, for example, as a payment?
Well, that's the thing, right? Like we're actually tracking efficiency, so we can tell you exactly what it is, and we've actually discussed that with our customers. Yes.
Great, great. Sorry, that were my questions.
That's a really good point.
Yeah. Any question? There's one from the audience, and please repeat it if possible.
Yeah, so I've been in the industry for 10 years now. I've only focused on metal. And if you say that you're going to focus on all these other things, you're lying. Because it's very complicated, right? There's a lot of things that you got to figure out. And so consciously, we don't do that right now, right? Like once we have a team of 50 people, absolutely. We already have the algorithms figured out. We've already been discussing with people that are on the polymer side. But we're not doing that because we want to deliver good value to our customers, right? And that takes a lot of hand-holding to get them into that step, and just speaking from experience.
Awesome. Thank you so much, mate. This wasn't never the first time. It was awesome. Thank you so much. And yeah, you can visit them at their booth. Thank you so much, and a lot of success for your
and you will
solution.
get limoncello if you give us feedback.
That sounds good.
I think that's a good sell, right?
Yeah, absolutely. Thank you so much. So, I remember the pitch last year very well, so I'm excited to see how their approach has evolved. Did you know that you can deduce quality based on sounds? It's still amazing, sorry. Still unbelievable for me. For Automation Acoustics and its CEO, Anthony Lele, it's a product. Anthony, let's share your idea with us.
Thank you very much.
I'm excited.
Well, it's
Thank
great
you.
to be here again, as I said, from last year. So we've had a lot of progress from what we're doing. Acoustics, anomaly detection. It's quite simple, but very complex when you get into it. The human brain is incredibly good at saying, I know what that sound is, when you're trying to train algorithms to look for that, identify that, and diagnose it, and then provide that in real time. We're talking about a whole new complexity. So this is what we do. We listen to the sound of your process. Just like a really good operator knows when something doesn't sound right, we do that with software. So because every sound creates, well, every process unique sound, a new feature, and you can associate that with a problem, that's what we focus in. We focus on these technologies of thermal spray, cold spray, laser-based direct energy deposition, both in powder and wire, and a lot of wire additive arc. Because as I mentioned earlier, these are the areas where those skilled operators often are listening up to the wall, they're listening to the sounds, they're trying to understand and pick up those nuances so that they can adjust. And that's what we focus on. But where these processes tend to exist now are in these closed rooms. They're very loud and you can't work within those spaces. They've got lasers and they've got dangerous powders. So getting that operator to get really close and understand what's going on is getting harder to do. So trying to create, again, that idea of what the human person is doing and building that story and understanding into data that's valuable and actionable is what we focus on. So we're a piece of the puzzle. Acoustics isn't to replace everything, it's a piece of the puzzle. It's part of the information set, just like we look and we smell and we hear and we do all these things, we even feel the machines we work with. Acoustics is part of that, and it's often regarded as the missing piece of Industry 4.0. So we look for different things associated with things like feedstock and consumables, when things are wearing out, and machine condition. These have been a really interesting thing that we've been focused on, but everyone thinks the process is good, but sometimes the machines start to drift as well. Well, what do? We use it in a way that allows for decision making, and we use a lot of AI-based techniques, machine learning, etc. to do that, but filtering out things, extracting out the things of relevance, comparing it against what you want it to be, that's really what we do. But being able to bring that together really quickly, but most importantly in real time, is how we do it. So a lot of people say, what do we do? Well, we take this sort of complex noise and we turn it into a very simple data stream. And those simple data streams are just relevant features that you want. We don't worry about the other things. What are the 2 or 3 things you really want to know? And then we present it. And this is a really interesting point because you've got to make data actionable in real time. So our operators, we create real-time graphical interfaces. And these interfaces change based purely on the acoustic features. So if you're working with an operator who doesn't quite understand what's going on, you can actually see and they can train them. They can actually start to believe and understand how that sound correlates with this process. So you're empowering, training, and getting a really good workforce to get faster at what they do. But the data, of course, still goes into the background and used for your own information. So these are typical kind of screens we use. We use our operators. They're the smartest people in the room to help train the process, train the algorithms. And that's really good. It helps with what we do. So automation acoustics, there we are. A real-time digital simulation. It's really powerful. We do for production consistency. You know what quality is. We're not determining that. We help you get it consistent for traceability and reporting purposes. All yours.
Awesome. Again, thank you so much. Anthony, big applause, please. I'm still, you know, I must admit, if you're not an expert and you hear that, it still sounds amazing for me. So I will ask the audience whether they have questions or not, because I'm not capable of asking one. Any questions from your side? It is amazing, isn't it? So please visit Anthony and his team at their booth, because I think it's worth it, and I will do probably, and try to understand it finally.
Wonderful.
But it's
Thanks
still
very much,
amazing. Thank you so
everyone.
much.
All right.
Pleasure to have
Great
you
to
here. So, yeah, coming to the last startup of today, and this is Christian Waldvogel, because he is founder and CEO of Spherene. I hope, and Christian, I never know, tell it for me, please, the correct pronunciation of the name of your Spherene. It's kind of difficult, isn't it? Yeah, okay, I tried to do it. I'm getting better and better, I tell you. So, you're working on a seemingly difficult task, at least from my point of view, reducing material usage while maintaining strength.
Or maximizing strength.
Oh, that is like somehow contradictory, but I'm looking forward to your speech. Stage is yours.
Hello, everyone. Thanks for being here. Oh. That doesn't look right. Well. So let me just talk to you about this orange thing that kind of like peeks out in the bottom right. That's a sample we do. The original one is to be seen at our booth. We invented a new algorithm to generate minimal surfaces, like the gyroid in a way, but adaptable to whatever you want it to be. So our algorithm creates an ideal geometry depending on the geometry that it surrounds, be it a ball or some complex thing, and adapting its density, the amount of material it contains, according to your inputs. They may come from a simulation or from a design aspect or whatever. So you can see here that you can do gradients, you can enlarge things, the density, you can make it smaller, and you can make complex shapes as the one you see in the center here, which is a satellite bracket that we developed for the European Space Agency. Now, the main difference between what we do and the classical triply periodic minimal surfaces is that we have a geometry that reacts equally in all directions. It's an anisotropic material. It's an isotropic material which has properties that are scaled linearly. Take half the material, you get half the strength. The geometry does not have an influence anymore on how strong the material is, but just the amount of material that is placed by our algorithm. We have 4 products that we are launching. We have an infill service, that's a web service that takes no input, just a model. You can see the bunnies on the top right, within which we can automatically fill this structure that is maximally light and using the least material possible. We have a configurator software where you can actually build density fields that are then being translated by our cloud service into this minimal surface geometry. We have an engineering version of this software, which will launch next summer, which will allow for the integration for simulation data. And we have the generally applicable API to which everybody can grant access and create their surfaces themselves. Yeah,
that's it.
Sorry, a bit thrown off by the chaos.
You never say sorry because, I mean, sorry for that you haven't had the right presentation, but you did it quite well. So I think we got the point. Any questions from the audience? Spherene. If not, I ask a question. I mean, I have seen the nice bunnies as an example, but what are current applications that you already improved or optimized with your software? Do we have one for us that you can mention?
We did a part for a wafer inspection machine, which is about 70 centimeters large, in which we could save 42% of the weight while keeping the mechanical and vibration requirements alive.
What are the main industries you are tackling with your solution in the first place?
At the moment, we're working with high-tech industries, aerospace and medical, but this is actually something that is aimed at everybody. So we are also addressing the maker scene, as well as industries of normal. Everybody that wants to kind of start using AM could do it with our system because it is printable without supports, even in SLM. So you can print efficiently without having to choose your best orientation.
Very good, very good. Any questions from the audience so far? If not, Christian, thank you so much.
Thank you so
Very
much.
spontaneous, very good. Thank you so much. Big applause. Yeah, let us give again our hands to all the startups for their courage and the interesting insight into work. What a marathon, right? 20 startups. I hope you enjoyed it. Was quite amazing from my point of view. Before we get to the award ceremony and hand over the Startup Challenge Awards and, of course, the AM Ventures Impact Award, I first want to talk to 4 amazing people about the startup culture and the financing. But before that, we are going to have a short round of highlights to take a deep breath and to be concentrated for the next session. See you in 4 minutes. Stay tuned. Thank you.